So now I want to use the graphing calculator to show you what the parent function looks like. Okay? To do that, we're going to go to the y equal, type in y equals x, and then we're going to graph it. So you can see what y equals x looks like on the graphing calculator. It starts at the point 0, 0, which means it's going through the point 0, 0, if you can really see that. And it's a straight line going up because the number in front of the x is a positive 1. Okay? Let's do the same thing for the quadratic. Go back to y equal. Let's type in y equals x squared and graph. Again, this is the parent function. This is that open U that I was telling you about, and it's open upward because the number in front of the x is a positive number. Remember, it's a positive 1. Okay? All right, so let's go back to the linear function. Let's go back to y equal. And what I want to do is I want to play around with it to show you how children can be made from the parent functions. This is like really so cool. So I'm going to type in y equals x, and then for the second function, I'm going to put y equals x plus 2. Let's graph it. So here's my first graph, and then my second graph is y equals x plus 2. Notice what happened when I put a plus 2 on the end. When I put a plus 2 on the end, it made the graph go up to positive 2 on the y-axis, the children of the parent function, or in this case, it's just a child. Let's make one more child, so then we'll have children. So let's go back to y equal. This time, I want to make the graph y equals x minus 3. And then I'm going to graph. Notice this time, the parent function has been shifted to a negative 3 on the y-axis when I put a minus 3 on the end of my parent function. So my parent function, y equals x, when I put a plus 2, it went up to the 2 on the y-axis, the positive 2. When I put a minus 3 on the end, it goes down to the negative 3 on the y-axis. So if I had to name them, this would be the children of the parent function y is equal to x. Okay? Now, let's do the same thing for the quadratic. We're going to go back to the y equals screen, and I'm going to type in the parent function for the quadratic, which is y is equal to x squared. We know what that looks like, an open U. But then, I'm also going to type in, for my second function, y is equal to x squared plus 2. Notice what happens. My parent function for the quadratic starts at 0, 0. When I put a plus 2 on the end, it goes up to positive 2 on the y-axis. Okay? What do you think would happen if I made it x squared minus 4? Let's see. So if I type in x squared minus 4, my parent function actually moves down to negative 4 on the y-axis. Okay? So these are the children of the quadratic function. Now, as always, you can have more children, but I do want to show you this. Sometimes the parents can be really negative, okay? If I want to make my parents negative, watch what happens. I'm going to go back to my y equals screen, and I'm going to type in y is equal to negative x, and then I'm going to graph it. Notice when I typed in y equals negative x, my line is actually going downward instead of upward. Okay? We talked about that in the table. Let's do the same for the quadratic. So I'm going back to y is equal to x squared. I'm going to take out my negative x, and this time I'm going to type in negative x squared. And notice what happens. Upside down parent function of y equals x squared. And that's because the numbers in front of the x are negative. Okay? All right, so now that you got that part, I think it's one more thing that you should show your class. More children of linear functions and quadratic functions. What happens if you change the number in front of the x? Let's start with the linear function. I'm going to type in y equals x, graph it, upward line going through 0, 0. But then, what if I wanted to make it y equals 2x? or y equals 3x? Let's graph those. Here's y equals 2x, y equals 3x. Notice that the line kind of slants more upward as my number increases, okay? That's called a slope, all right? The more my number increases, the more of a slope I have, kind of like if I'm skiing. So let's do one more. Let's make it y equals 6x. More of a slope, it's going slanted, okay? So when I change my number in front of the x for my linear function, I get more or less of a slope. What if I were to make it less than 1? Let's make it y is equal to 0.5x. Notice that the slope or the line is actually below the line y equals x, okay? Sounds pretty simple? Check out the quadratic. Let's go to the quadratic. So I'm going back to my y equal on my graphing calculator, and I'm going to type in y is equal to x squared. Make sure you put x squared and not x2. Okay, so here's y equals x squared. What happens if I wanted to change the number in front of the x from a 1 to maybe like a 2? So let's type in y is equal to 2x squared. Wow, notice what's happening. Let's try one more. Y is equal to 3x squared. I don't know what's happening on your calculator, but for mine, it looks like the graph is coming in more. It's closing in. I wonder what I can do to make it come out or open wider. Maybe instead of increasing it, I'll decrease it. So let's make this y is equal to something less than 1. 0.5? 0.5 x squared? Wow. It makes it bigger than the parent function y equals x squared, meaning it's more open. Let's try one more. What's something less than 0.5? 0.4, of course. 0.4 x squared. Let's see what happens. Whoa. Cool graph. So you can see that you create more children as you change the numbers. So when the numbers are changed in front of the x on your graphs, you get different pictures. Okay? The best way for you to learn this is to explore it for yourself. So take time to use your graphing calculator and see what happens if you make it negative 3x squared or negative 0.5x squared or negative 0.5x. Do it on your graphing calculator. I'm sure you'll have fun exploring.